The quadratic formula. There are many different methods for solving quadratic equations, and the quadratic formula is one of the methods. The benefit of the quadratic formula is that it can be used to solve any quadratic equation, even if you can't factor it, and that's a big plus. So in order to use the formula, you have to put your equation into standard form, just like you would if you were solving by factoring. And that would be with it set equal to 0. And then you want to have your x squared term first, your x term next, and your constant next. And then you can look at the coefficients for each of those terms, the number parts, and those will become your a, your b, and your c. Those are the values in the quadratic formula. And you can see here the quadratic formula. I have b there, I have a b there, and then a c here, and then a. And there is a song you might know that goes to the tune of Pop Goes the Weasel, and it's x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And you can use that song too to help you remember the quadratic formula. But the important thing is that you use your order of operations when simplifying the quadratic formula. And we've worked on that already in the order of operations 2 that you should have watched a pre-class video. So if you're struggling on this and you keep getting a different number than I do, you should go back and watch that video to see what you should do first, second, and so forth. Okay, so solve the following using the quadratic formula. I'm thinking, first thing I notice is that it is set equal to 0 and it is in descending order by the exponents. So I have the squared term first, the first power, or just x term next, and the constant with no variable at the end. So I know I have it in this ax squared plus bx plus c form. And then I can also see that my a is whatever that coefficient is, which remember, if nothing's showing, there's an implied 1 there. My b is the 6 and my c is the 8. So when I put it in order, descending order, I can just match up. The first number is my a. I want to make sure I take the signs also, but I'm going to just write it. A equals 1, b equals 6, and c equals 8. And all of them happen to be positive on this example. Now I want to plug into my formula. And so I'm just going to write out x is equal to, negative is from the formula, and then the b is a 6. So I'll plug in a 6 plus or minus and the square root, and then we have b, so that's going to be that 6 again, quantity squared, minus 4, that comes from my formula, and then times a, which is 1, and times c, which is 8. And then all of that over 2 times a, and my a again is a 1. So when I start working this out, I have x is equal to negative 6 plus or minus square root. 6 squared is 36. And then I have negative 4 times 1 times 8. So negative 4 times 1 is negative 4 times 8 is negative 32. And it's all over 2 times 1, or 2. Simplify a little bit more. The order of operations here should be pretty familiar to you because we've worked on that separately. And I have 36 minus 32 under the square root. That comes to a positive 4 over a positive 2. And the square root of 4 is 2. So I can rewrite it as negative 6 plus or minus 2 over 2. And I know things are going to reduce. I'll try it out. So negative 6 over 2, I'll break it apart, plus or minus 2 over 2. And then I can reduce things. 2 goes into 6 3 times, 2 goes into 2 1 time. And then I can rewrite it. I have negative 3 plus or minus 1. That means I have two answers. One of them has the plus from that middle, and the other has the minus. So I have negative 3 plus 1, and I have negative 3 minus 1. So negative 3 plus 1 is negative 2, and negative 3 minus 1 is negative 4. So my two answers are x is equal to negative 2 or negative 4. Next one. I'm thinking about ax squared plus bx. Oh, and that one doesn't have the negative 3 on the same side. So before I can even think about the order of the terms and so forth, I need to get all the terms onto one side and just a 0 on the other side. So to do that, on one side of my equal sign, I will add a 3, and on the other side, I will add a 3. That will keep things in balance. The negative 3 plus the positive 3 here gives me a 0, which is perfect. That's what I was after. And on the left-hand side, I don't have any like terms because I have a 2x squared and then a negative 9x and then a positive 3. None of them have the same variable to the same power, so I can't combine anything. I have 2x squared minus 9x plus 3 equals 0. Now I'm ready to look for my a, b, and c. So I'm thinking ax squared plus bx plus c equals 0, and I have it in the proper format. So my a is a 2, my b, this is a little tricky, is a negative 9, and my c is a 3. So this is an example where you can see the negative on the b, the negative 9 right here, has to go into the b right there. Now plug them into the formula. So I have x is equal to negative from the formula and then negative 9 for my b, plus or minus square root negative 9 for my b squared minus 4 times a, which is 2, times c, which is 3. All of that over 2a. 2 is my a, so I'll plug that in. Now I want to start simplifying this first part, the opposite of negative 9 or negative 1 times negative 9. Either way you want to look at it, I'm going to get a positive 9 plus or minus, and then I can look at under the square root. I have negative 9 quantity squared. Remember that means negative 9 times negative 9, so it's coming to a positive 81. So I have 81 for that squared part. And then I have negative 4 times 2 times 3. So negative 4 times 2 is negative 8. Negative 8 times 3 is negative 24. And I'll make that a little bit smaller. 2 times 2 for my denominator is 4. Now I can simplify a little bit further. I have 9 plus or minus 81 minus 24. So if I subtract those two, I get 57 over 4. Now I know 57, I'm pretty sure is a prime, but let me try something. If I add up 5 plus 7, I get 12, and 12 is divisible by 3. So 57 is divisible by 3. Let's check it out and see if we can simplify here at all. So 57 is divisible by 3. So I just, on my calculator or in my head, I can divide it, and I get 19. Now 19 I know is prime. So square root of 57, even though it did have factors, it doesn't have any pairs of factors to make perfect squares. So the best I can do is leave it as a square root of 57. And then my two answers, one of them is 9 plus the square root of 57 over 4, and the other is 9 minus the square root of 57 over 4. Now those are my exact answers in reduced radical form. These are exact. I can also calculate these with the calculator and get decimal approximations. So to find the decimal approximation for this problem, I'll start with the 57. So type in 57
take the square root, and then I will add 9, so plus 9. And then last thing, I will divide by 4. And I get 4.137. And if I stop there, I can see that the next digit is a 4, so I should leave the digit I rounded to as a 7. And then my second answer, I take the square root of 57 again, type in 57 and then square root. I want to change the sign, so I'm going to use this little button here, change the sign to negative, and now I have the negative square root of 57, so I'll just add 9 equals, and now divide by 4. And for this one, I get 0.3625, and since I have a 5 following, I need to bump the 2 up to a 3. And so there are decimal approximations for my two answers and the exact answers that had the square roots.